So get yourself started on that fraction problem there. You know, I've got a couple techniques we've presented, we've used at this point. If somebody really wants to see one version or the other, let me know. I've been, I guess, leaning towards just work with the fractions. See what happens. I assume that's visible. You'll always have to let me know if something's weird with like the lighting or something. I don't really have studio lights in here or anything, so it varies from day to day depending on what comes through my skylight. Watch out. Make sure you hang on your minus, your negative signs. There's one step. What I might do. I don't know why I often move the x's first. Totally arbitrary. You might like moving the constants around first. Makes no difference. Well, you should do it right? Just be careful, huh? I'm going to subtract the 2. And then I'll wait. I'm going to write it as 2 over 1, knowing what we got to do after that. See what you come up with. Hopefully we're kind of at that point together if you're doing the problem this way. The question often comes up, does it matter which side I move things to? If you recall, that came up a while ago, and it doesn't. But really what happens is all the signs get completely reversed. And so what was positive on positive and positive becomes negative and negative. And so the answer always works itself out to the same number. There you're going to need a common denominator to put those two together. And here you're going to need a common denominator to put those two together. Notice they don't have to be the same in order to combine those. Now what's the smallest number you can get for 6 and 8? Yes, it's true. You can always do 6 times 8 because those. 24. But 24 is better, right? It's smaller. I like that better. We go to 24. What do I have to do here? So 3. And over here, it's 4. Squeezing it in there, right? Oh, let's get this in here. Good. So I have 15 minus 4, bunch of x's. It's a quantity, a fraction of an x, whatever that means. And let's see, I got to do the same here. So got to get threes, right? Minus 2/3 minus 6/3, right? Yeah, start talking and loosen things up. I was just getting them in a shape so you could combine them. Now, how many 24ths do I have left here? I would come down to 11. Over here, don't try to cancel anything when you're adding and subtracting, right? You can't cancel out anything. That's just going to be negative 8/6. No, but it's a weird fraction answer. There is a little simplifying you can do.
The 8 and the 24.
Say that again?
The 8 and the 24.
Dividing, right? The 8s and the 24s, yes. Simplifying, I think, if that's what you're talking about. Yes. So I'm going to cancel the fraction by multiplying by its reciprocal. This is the one I have to get rid of, not that one, right? I want to get rid of the one on the x's, but I got to multiply by the same number on the other side. Doesn't matter what's over there. You got to multiply by this fraction, that reciprocal. Wait, whoever said 8 and 24, it's the 3 and the 24, right? I was thinking, yeah, the 8 goes in 24, just like, make sure this is what you get. Notice I had to multiply by the reciprocal. So it's 3's that cancel out. I'm not sure if we were agreeing or not, whoever did that.
No, I was in a completely different step, so disregard what I said.
Okay, and I say it a lot, there's different ways to do it. And if you're at, if we get to the same place, that's fine. So divide by 3's here. So I get, what? Don't lose your negative 64 over 11. See if that's what I get. See if you get there.
That was the answer I got. I was nervous to say that was what I got because it was such a big number.
Yeah, I tried to make you feel okay. It's a weird fraction, It doesn't turn out to be a real simple, nice little one or something. Yeah, that was it. I just make up these numbers here to, start with things that don't look too crazy, but by the time you mix them together, you might say, you get some funny looking big numbers. So that just happens.
What if I switched it? What if I put the 11 on top and the 64 on the bottom?
Please say that again for me.
What if I put the 11 on the top and the 64 on the bottom?
How did you get
that? Work?
Right? I mean, was there a step early on where that fraction turned upside down? I mean, did you multiply by 11 over 24 or something? Or why would, I guess I'm wondering, what were you thinking? What made you come up with it upside down?
I did 8/3 divided by 11/24.
Oh, it's not divided by, right? Here, in a sense, maybe you just said it. 8/3 divided by 11/24. So if that's what you just said, how do we divide by a fraction?
Oh, okay, got it. Figured it out.
Did that click? Did that click when I said that?
Thank you.
Right here, I didn't show dividing by 11/24. I showed by multiplying by its reciprocal, which is which is what that turns into. you know, if those ideas are still jumping in your head, it's good good that we talk about them again, okay? Anybody else with the issues on that answer? All right, I'm going to put up another problem. Make you work for a little bit here. What else? What did I have next here? And Bill's check was $150 less than twice of whoever, Mary's check. Together they earned $2,400. How much did each earn? Your favorite. Thought we better practice something like this again, a word problem. What are we looking for? Well, we're looking for how much they both earned, but whose amount is the problem described in terms of, right? So you could say, well, eventually this is asking for both amounts, but the description is based on Mary's amount. So you might say something like, oh, I'm going to use let M be Mary's amount, right? Okay. Now, maybe that'll help you get started, because now I got to write something that describes Bill's amount. Then eventually it says together. So you're going to add them together to solve. Helping you too much, maybe. Ha. What expression describes Bill's earnings in terms of Mary's?
So Mary's amount is X. Would it be like 2X minus the 150?
Perfect, perfect. Yeah, you could say Bill is, and I used M, so 2M minus the 150, that's Bill. Very good, very good. Now it just says together. So now I'm going to add those two expressions together. The plain old M plus this one has to equal the 2,400.
Does it make a difference in what order you have it in?
Not if we're adding,
Okay.
right? I could do Mary plus Bill or Bill plus Mary.
Okay, thank you.
Yeah, yeah. As long as this is all together, that part of it, right? If it was a difference, then we'd have to read the problem carefully to figure out who was subtracted from whom. Right, so I'm just going to say Mary plus Bill equals something like that. I sketched this out on paper. I hope I made nice numbers for myself. I hope I didn't do it too fast on my paper. I put all those M's together, right? Hopefully that makes sense. Like terms, they just, we don't even care what they stand for at this point. We're just working with the expressions and the numbers. If I add the 150, can I do that without showing it? 2550. If I add the 150 to both sides, now you got to divide by 3. I think that comes out easy.
I'm a little bit confused.
Pardon?
I'm just a little bit confused. What I had on my paper was just 2m minus 150 equals the 2,400.
Uh-huh.
Where does this other m come in?
This one, notice this particular sentence. Sometimes that's all those problems say, Bill made this much and it was twice, or it was, 150 less than Mary. How much did Bill make? But this said together they earned. So I had to add them. This stood for how much Mary made, and this stood for how much Bill made. So I had to actually add.
Okay, that makes sense. Thank you.
Yeah. And I think that came out as M was 850, if you get there, folks, right? Let's hope she's working part-time compared to Bill, and this is not income disparity, wage differences. There's my social comment, right? So twice that minus 150 was, so Mary made, and I think Bill 1550. If I problem asks for both, then be careful to figure them both out. So yeah, I tried to make up not too unusual, but about as complicated as those real verbal problems get. Had to come up with two different expressions. Had to figure out what you could relate it all to, and it was all based on Mary's income. So I had to describe Bill in terms of Mary, and then, like you say, added them together. Is that okay? Okay. Let's see. All right, moving on. We will get to 3.4, but we have 2 days for that topic, that section. Again, mentioning no class on Monday, President's Day. Next Thursday is our test, chapters 2 and 3, but we always have our review day. I'll go over a little bit of everything on Wednesday. Okay, still dealing with our percents from yesterday, okay? We talked about percent increase, percent decrease, a related sort of couple concepts are, discount amount and markup, right? Discount. So let's say a belt on sale, 40% off sale price is $29. What was the original? And sometimes they ask for what was there for the amount of discount. Hopefully, this is very much like yesterday's where, we had percent increase, percent decrease. After a 40% decrease, it's $29. So what was the original price? Once you have the original price, you can figure out, well, what was the difference? What was the amount of the discount? This is that one of those like yesterday where I would say, okay, it was 40% off, but what percentage does that mean you paid? The 29 is what percent of the original? That makes sense, huh? You might say, what was the original and amount of discount, huh? If it was 40% off, hopefully that it's clear that what you are actually paying is 60% of the original price. From that, now I try to usually write that concise sentence, something like 29 is I'll stop there, but that's probably giving it away. But hopefully that's making sense based on what we did yesterday. Something like that. Divide by that, right? 29 is 60% of what we're looking for. Oh, I got a repeating 33333. Huh? Made up some numbers, didn't work out even. Did you get that? Did you get there? All right with that one, folks? I don't know. Thank you, Kaylee. I couldn't tell from that look. All right, that work okay for you? Hopefully. One more of those and then we'll go on. One more related here.
Don't we have to figure out the
Oh,
amount?
there you go. Thank you very much. Amount of discount. So if hopefully that makes sense that this was the original and it was reduced to 29. So if I subtract, it caught me there. If I subtract, I'm going to get whatever. Yeah, it's still my calculator. I just do minus 29 and get, whoops. I got 19.33. That can't be right, right?
That's what I got.
That's what I got too.
Shouldn't they? Oh. I was trying to think, shouldn't they add up to, well, yeah, they add. I didn't like this 333. I was thinking, it should be 6. No. That's me. That was my problem. Yeah, the amount of discount, 1933. All right. Again, one more sort of related context problem. When a retailer buys their items to sell, they buy them at wholesale price, and then they mark them up to selling price, and that markup covers their wages and overhead and cost of operating their business. So markup is a concept where it's the amount of increase from wholesale price. Okay, and so let's see, where's my good problem? Let's see. Buys items to sell, then marks up. %. This is not unusual. Often a retailer would almost double their price in order to recoup their operating costs. What was the wholesale price? So they bought the items, she bought the items at a certain price, marked them up 80%, and now her selling price is $72. What did she buy them for? What was her wholesale price? Again, this is one of those, what percentage are you really paying kinds of problems. And this is more like the percent increase rather than the percent decrease, right? She's adding 80% to her costs. What percent do you pay? Well, she bought them for 100% of what she bought them for, duh, and added 80%. This is what I'm getting at. See if you can go from there. Make sure that makes sense. That selling price is 180% of what she paid for it. What she paid for it. First time people hear this kind of problem, say, oh my gosh, they're marking up so much, they're making a huge profit. Nah. It costs, I think I've heard figures like anywhere between, 2 or 3 to 5%. They call it their margin, maybe. They might make 2 or 3% profit off of things when they sell them. If they can do that, they maybe can survive after they pay all their expenses. I don't trust used car salesmen, though. That's not fair. But let's see. 72 is 180% of what we're looking for. All right, does that make sense? And I did work this one out earlier. She bought them for $40. Did you get there? Does that work for you? So markup or discount, it's really a amount of increase, amount of decrease kind of problem. What percent did you pay? There are no issues with that. I'm going to go on now, and we're going to go to 3.4. Here it goes. 3.4 is named as a geometry section. We're going to use a few of those same formulas that we used earlier in the term. You might want to fill out that formula sheet for yourself, but really we're going to add in a few new concepts to our geometry idea. But we're going to start with our good old favorite rectangle. All right, so I call this the length, call this the width. For yourself right now, can you write down the perimeter formula for a rectangle and the area formula for a rectangle? Do you know those well enough? You can do that without looking. We've done this one several times.
Area is length times width, and perimeter is 2 length plus 2 width.
2 lengths plus 2 widths. Very good. All right. So hopefully everybody's okay with that. All right. So, and if I tell you the area is 168 square feet and the length is 14 feet, find the width and perimeter. It's plugging numbers that you know. We have to give you enough information, right? Plugging numbers you know into the right formula and then solving for the number in the formula you don't know. Here's that similar to what I did a couple days ago where I related it to our solve a formula for a certain variable. Well, you don't have to rearrange the formula really. But if I start out with this information, which formula am I going to start with?
The area?
I know the area formula and I know the length. So by plugging the values I know into this formula, I can figure out what the width must be. Then I'll know the length and the width, and I can go back and figure out the perimeter. Hopefully that makes sense, huh? Is it 12? You know, divide by 14 goes once, with a 28 is a 2. I believe I get 12 feet. Hopefully I didn't go too much faster than you there. Hopefully I didn't go faster. Does that work for you so far? Let me know if there's a problem with that. So now I've got both dimensions. I can plug them into my perimeter and say, perimeter equals 2 times 14 plus 2 times 12. There you go, huh? Now, notice, I just popped in my head, the area was square feet, right? Little square, little square, little square. But we kind of broke it down into the 2 dimensions, and those are just lengths, feet, not square, right? Just 12 feet. Similarly, the perimeter is just feet, not square. Whatever this is, 28 plus 24, 52. $52 feet perimeter. Another one. All right. Time for good cleaning. Anybody remember the formula for the area of a triangle?
Half times base times height.
Very good. Yep. Imagine it was a triangle. It looked like this, right? Here's our base and here's our height. Whoops. Height. Just a little side discussion here, right? Where does that formula come from? Half a rectangle. Base times height would be length times width, would be the area of the rectangle. That cuts it in half. So that's what you get with the triangle. And you can even see if I took this little piece, if I doubled this, really get a parallelogram, but I took that little piece and stuck it over here, and it just makes a rectangle. So triangles you can always cut up and turn into half a rectangle. That's where that formula comes from. Half the length times width. All right. It's the kind of thing, you know, math teachers get excited about, right? If area is 25 square inches and the base is 10 inches, what's the height? Okay, again, so far, it's working with a formula that we either found on our sheet or we're familiar with. Plug in the values you know. It's not all going to be all the nice stuff on one side. There's going to be one of the ones over there that we're going to have to solve for. The area is 25. So that's what we're doing here. Base is 10. And the H is the unknown. So you could do this a couple of ways, but just looking at the nice numbers here, might as well multiply, right? 1/2 times 10. I was concocting this. I was thinking, okay, multiply by 2, get rid of the half, and then divide by 10. But it works out nicely this way. Makes sense, right? And of course, now, remember your units always. Oh, I was in inches, duh. Remember. 5 inches, must have been the height. So if we're dealing with these basic shapes and we have the formulas to work with like that, we're going to be given everything except one of those values, and we'll have to manipulate it to solve for that one unknown dimension. All right, some other information about triangles though we're going to play with. Oh, I always like to do one more. Let's see, this one's a little circle. What's the formula for the area of a circle?
Pi r squared?
Pi r round, no, pi r squared. Okay. And let's see if I make up, I'm just going to make up some number. It's going to come out really weird, okay? I know the area is, oh, I'm going to say 120 square inches. What's the diameter? What's the diameter of that circle? Gonna need your calculator definitely here. So same kind of problem where I know, really I know the one, there's only 2 variables in this one. Pi is an exact number, not exact, but pi is an actual number, right? So 120 equals pi times r squared. All right, so what's the first step I'm going to do here? And I need my calculator.
Are you going to divide by pi?
Yeah. It's got its own special symbol, but it is just a number. Divide by pi. Now, if you've got your calculator handy, I encourage you to just do that. Use the pi button and don't do any rounding in your calculator. Don't round it in your calculator. 120 divided by pi. And I'm going to write a bunch of decimals here. 38.197, roughly 2, okay, is r squared. The radius squared. How do I find the radius? How do I undo squaring? What's the opposite operation of squaring? We need this Tuesday in particular. What's the opposite of squaring?
Divided by 2? No.
Remember this thing? Square root is the opposite of squaring. Remember the square root thing? Irrational numbers. Sometimes they work out even and sometimes they don't. So you've got a special button. It's probably connected to the square button. But I want to find the square root. Now on my calculator, it's one of those second functions. So I have to do push the second first and then go find a button that has square root on it as the second function. On my calculator, it's the button that I can use to square a number. The opposite or inverse function is the one that's the second function of that button. So there's actually a nice way to be able to just say square root and plug that number in, but I'm going to start over. So I'm going to go find this function. Can you access that on your calculator? So you're going to get, usually it presents the square root, and then you have to tell it what to put inside. Like mine says, all right, here's a parenthesis, tell me what to put inside. And I'm going to put in this 38. Roughly, look at 38. What number times itself is close to 38? What we expect the number to be in the neighborhood of If you only got one number in there, you don't really need to close your parentheses. But, you know, if it was 5 squared, it'd be 25. If it was 6 squared, it'd be 36. If it was 7 squared, it'd be 49. So it's going to be close to a 6. You should expect your answer to be close to 6 is what I'm getting at. And this kind of problem, which should definitely tell you, you know, how many decimal places. I'm going to go 2 decimal places right now. Did you get there? Does that make sense? That's the radius. And what are we in inches? So from this area for a circle, we had this squared quantity, a little different when you're using circles, right? So I had the square root. What number times itself gets me to there? And it's something a little bigger than 6. Now, carefully, if you look at the problem I made up, it says, what's the diameter? I'd have to double that for diameter. I'm using up all my time today. Diameter. And I'll call it 12.36 inches without doing any more rounding, okay? We do have to do more square roots on Tuesday when we talk about Pythagorean theorem. Don't get too hung up on that. We'll do it again. All right. Copy it down and think about it. I didn't really see a circle on your homework, but it is related to this section. You know, if we've been doing textbook problems, you would have gotten assigned something like this, but Mom didn't get that complicated. Good practice. I do want to talk about triangles one more time. All right, I'm going to erase that. That's somebody stops me. Features of triangles, some things about triangles. One more thing that some homework problems are based on. Triangles, right? They have 3 angles. I'm just going to say angle A, B, and C. Right? There are a certain number of degrees. Right? We have come up with a measure of degrees. I'm going to not get too much farther today, so I'm just going to go off one little more side trip. I went all the way around a circle. Do you know how many degrees? How many degrees have I turned? If I turn all the way around?
360.
360 degrees, right? Now, why in the world, way back when, Greeks probably, would somebody have chosen a number like 360 for the time it takes to go all the way around? I kind of almost just said it. 360. What's that really close to physical world number? A year, right? 360 days for the Earth to go around the sun. I think the Greeks figured that out. 365. But anyway, that's why we come up with 360. Side trip. Triangles. Do you know, if I add all those angles together, you know what they add up to? Heard that before? This degree plus this degree plus this degree. Triangles always add up to 180 degrees. Whatever the triangle shape, you know, it could be real skinny and a big one, but whatever the triangle shape, they always add up to 180 degrees. If you were in a geometry class, you probably prove that, break it down. So based on that, we'll get some problems that say, oh, this one's 25 degrees and this one's 35 degrees. The drawing is not at all to scale. Well, how many degrees must that one be? And that one's supposed to kind of look like the easy one there. Add them up, right? Or subtract. 25 plus 35 plus X have to equal 180. They always add to 180. So you could subtract and figure out what that missing one is. I know there's one in your homework. Looks something like this. much are those angles? This drawing is telling us that two of them are the same. Right? Two of them are the same.
They're both 90.
Can't both be 90s because that's already 180. What about this extra 40? See?
It's 70 each.
I think that's more likely. Whoever said the 90, but hopefully this makes sense. I have to add all three. Do you get there now? Subtract the 40. That makes sense. If I have 90 and 90, oops, that triangle's never going to close. How many, that might start you out though, how many degrees are always in a rectangle or a square? Right? 4 times 90, a square or a rectangular solid, a four-sided solid, even a trapezoid, they always add up to 360 degrees. We're not going to get into that kind, but we're going to do some triangle kinds of problems like that. Okay. Divide by 2. So you can get that little degree symbol in there somewhere. Probably available in Mom. All right, and let's see. One angle is 2 times another, and the third is 5 more than the first, or than the other. Put it that way, however, other first. One angle is 2 times the first. You know, find the angles. Oh, this is one of those, like, I got to get 3 different expressions. Here's the other, or the first one. Another one is 2 times that. Oh, so there's the other one. And the third one's 5 more than the first one. Oh, x plus 5. So it's this kind of idea. It's all related to one of them, and so I have to come up with 3 expressions based on one of them. And now what are those angles? Well, they all still have to add up to 180. So now I got a bunch of x's and I move the 5 and looks like I have 4 x's, right? This one's not going to work out to be a nice number. I just made it up. 175 divided by 4 is going to be some fraction. It's going to have a decimal part. Was that going to be 63 point something for your calculator? But the point was, this kind of construction for the problem requires you to come up with those 3 different expressions, or an expression for each of the different angles, and then combine them. That's going to get you through like the first half a dozen problems in Mom today, I think, for 3.4. A good chunk of the rest of them have to do with what's called the Pythagorean theorem. If we have a right triangle, there is a relationship between the sides in a right triangle. Right triangle means there's a 90 degree in it. So there's a relationship between those side lengths, a little formula that we have to know how to use. And we'll focus on that on Tuesday. Okay. If you're working on it, we're there already, basically. If you're trying to do that homework on your own and you have questions about that, you can send me questions this weekend, okay? And I'll get you going. I'll help you out. Okay, but otherwise we're out of time today, folks.
I have a question after
Sure, no problem.
you.
Okay, so otherwise we're done, and have a nice long weekend. Won't see you again until Tuesday. Okay? All right, have a good day, and I won't cut you off. See you later. Yeah, if you want to stick around, anybody for a question, that's all right. I'm in no hurry today.
Are
Yeah,
the lessons
go ahead.
from yesterday posted on YouTube yet?
I'm sorry, say that again, whoever.
Is the lesson from yesterday posted on YouTube?
Yes, it is.
Thank you so much.
It
Have a
ta-
good
it-
weekend.
it takes me a while, at least an hour, usually after class, I run out and do an errand, but anyway, it takes a while for it to format itself, and then I have to post it to YouTube. So they're not always available. They're never available immediately after class. It's always at least an hour. But yes, that one's up there from yesterday.
Thank you. No worries. Usually in my other classes, it takes a couple days for them to be posted. So
Oh. I always get it the same day.
thank you. Have a good weekend.
See you later. Pardon me. Go ahead. You have a question, Kayleen? Is it one we can share with everybody? Is that all right? Or is it more personal?
Yeah, it's one of the homework ones.
Okay, let's see what you got.
One
Is the hand in homework question?
mark, yeah.
Whatever. I'm good.
So is that okay that I'm doing it?
Yeah, well, yeah, I might not tell you the whole answer or something. I might say, try this, all right? Tell me show me your question.
I have tried. I just need help finishing.
Yeah.
I don't know exactly how to finish it.
That's
So one minus 2/3 x
1
equals
minus 2/5 x.
2/3 x
There, 1 minus 2/3 x.
equals 12/5 minus 1/5 x.
1/5.
Yes. Yeah.
That's just like the ones I started with today.
I know.
Okay.
My brain got me.
Have you been doing okay with a couple examples recently with these fraction problems? In fact, I did one today that had a whole number in it.
I know.
Oh.
I forget to flip the reciprocal. That's what I forget to do.
I guess it's obvious. I shouldn't give you a hard time. But all right,
It's
what we've been doing lately is moving things around so all the x's are on one side and all the constants are on the other side. Can you do that? What do you want to do? Which way you want to go?
I usually move the whole numbers first.
Okay, or the constants, Which side do you want to move them to?
Over to the 12 and 12/5.
You're going to move the 12/5?
No, I'm gonna move the one over to the 12/5.
Sorry,
It's okay.
So we're doing that, right?
Yeah. How exactly?
The sign still stays with this fraction, right?
Yes.
Now, maybe I'm going to just squeeze this one in right next to this one because we're going to do something with this thing in a minute, right?
Okay.
Now what are you going to do?
I'm gonna add the 12/5 to the one.
Okay.
Sorry, minus 12/5 minus 1.
And how are you going to express that one? You're going to leave it as a 1 or?
I was gonna do what I did before is what did I do? Shouldn't I get a common denominator?
Yeah, 1/1. How do I turn that into fifths?
Fifths, yeah. So it's 5/5.
There you go. All right, so you're doing all your work with your constants right now. All right, so 12 minus 5, 7. 7/5.
I got 1 2/5.
Well, don't try to make it into a mixed number. We never work with mixed numbers, really. How are you going to multiply or divide or subtract with 1 2/5? I need this.
Mm-hmm.
I need this improper fraction.
Yeah.
It's top heavy, but there's nothing wrong with that.
I got it.
You got to get your x's together now.
Yep.
Okay. So that's all over there. So you're going to move this one, right?
Yeah, I'm gonna move that one.
All right. By adding, right?
Minus 2/3, right?
Not times, we're adding.
No. Yeah, but it's 1/5 minus 2/3. Right?
I just had to double check. Anytime I'm dealing with a negative, I'm a subtraction. I always make sure the order doesn't matter. We're adding a positive, we're adding 1/5, so it doesn't matter. if I was subtracting, it would have to come after, you might say, first one minus the second. But here we go. Negative 2/3 x plus 1/5 x, or like you said it the other way around. Totally, I'm going to write it the way you just said it, and it means the same thing, right? 1/5 x minus 2/3 x, and just 7/5 over here, huh?
And it equals 7/15.
Ooh, where'd you get the 15 from? Are you talking about this side equals 7/15?
No, the other side. I had the x's to I minus the x's
You already
to.
did it. You already did it. So I got to get a 15. You're right. So this will be times 3. There's 3/15. And this is times 5 minus 10/15. How about negative 7/15?
Yes. Sorry. I
Okay.
forgot the negative.
Negative 7/15 of x equals 7/5. Are we on the same page there?
Yes.
Now what?
Then I times by the reciprocal
Yep.
of negative 15 over 7.
Yes.
Okay. And then I cancel out, correct?
That would be very good. Here, that's going to get me my plain x, right? I'm
Yeah.
going to cheat and not write it down over there. So I'm going to, yeah, I got lots of canceling over here. It's kind of nice, huh? 7s go away. Divide by 5. X equals,
3.
not quite.
3 over 1. Negative 3 over 1.
There,
Gosh.
gave you a hard time, but yeah, that's important, right? Don't lose the negative.
Yes. Okay.
That's all fine. That was good.
Okay. And do you guys have questions?
They like watching your questions. Maybe Krista does.
And I have another really quick question. Are we required to do the discussion questions or just the discussion?
This, you might say yes. Discussions, the discussion is 5% of your total term.
Okay. Okay, I thought that was optional. I'm sorry.
I'm looking for 2 posts a week. Post or reply. Anything you want to say, just communicate with each other twice a week.
Okay.
Okay? Post something.
I'm sorry, I forgot last week.
Yeah, like I said to somebody, every week is worth 0.5% of your overall grade. So you miss a week, and then really if it came down to you being that close to passing the class and it was based on one discussion week, I would ignore it. I wouldn't. Nobody's going to fail because of a discussion grade. I'm just trying to generate this interaction that you guys really have been doing amongst yourselves, and rather than being in the class and having study partners and things like that, just trying to get you to chat amongst yourselves on the forum.
Yeah. Thank
Okay.
you.
All right, good. Chris, did you have anything or are you just watching, huh? Anyway, I'm going to go then. So
All right, thank you.
you're welcome. See you.
All right, bye-bye.
Whoa. Have a good day.